Let me say a few things about our motion control system called Nexonar. Nexonar is based on the infrared tracker, as you can see on, for example, my hand, or as you can see on the tool. If you have a look through the camera, actually there are some LEDs. I see the blue one with my eyes, but with my human eyes I don't see actually the other ones which you can see through the camera. And the reason is because they're operating in an infrared spectrum. The reason why we decided for the solution to have active trackers, those are emitting the infrared light, is first of all the reliability, because unlike the systems with the passive trackers, the system is not being disrupted by different lighting conditions, and also the precision. I mean, if I speak about larger trackers like this one, the precision actually is going down to 0.1, which we normally don't guarantee for usage. When we speak about the real usage, the working trackers are having precision of 1 millimeter, and even this one is actually not really used in the real scenario, because if I, for example, have a look on the tool, even the wobble of the bit is actually more than 1 millimeter. Yeah? So normally, and even the distance of the screws is normally not smaller than 1 centimeter. But the principle is that if you want to guarantee that you'll be able to secure 1 centimeter difference in any case of scenario, your precision value should be much higher. So we speak, our system is working with, let's say, 1 millimeter. So that's the main reason why we are actually having this type of solution and not some other. Yeah? Also, the important part is that if you have a look on the tracker, it's nicely visible on this one. You see that one LED over here, you can see it also on this one, is always slightly lifted above the surface. And the main reason is that because of these small differences, we can allow to have only one camera seeing one tracker at a time, because the system is actually able to understand how exactly is the tracker rotated in the area, without the need of 2 cameras seeing one tracker at a time. For example, this one is having one tracker from one side, other tracker from the other side. And because of this pattern done, and that is actually programmable and adjustable, the system can understand which tracker is which one. So the one system can differentiate between 16 different trackers within the area of one camera. Of course, if there is a need to go and to tighten behind something, the only thing that I need to do is actually just to add another infrared camera. We just have a small, tiny cameras which can be placed almost anywhere, and we are able to cover really large area, such as aerospace installation or even the complete warehouse. It's a real case scenario that we are actually having the hand trackers, and the operators are going through the warehouse and picking the components. Okay? Important thing to mention is that the system is understanding something we are calling the virtual point. Yeah? So if I actually have a look on this tool, I have the tracker in this area, but in reality the point of the touching of the product is here or here, depending on the length of the bit. Yeah? So for each bit I can set actually different virtual point, and then the system is constantly recalculating where exactly is my virtual point in this in the area. Yeah? When I say it constantly, the system is actually having the refresh rate up to 163 times per second, which is allowing us not just to control point A and point B, but we are actually able to control the movement, which can be then used for gluing application, painting application, or maybe pressing of the rubber isolation into something, simply to evaluate not just the point, but even quite a quick movement, which can be quite important. Of course, the system is allowing us to set up different zone of tolerances. Why is it this is important? Because, for example, imagine that I have a screw which is 10 centimeters long, plus or minus, okay? So I actually start to tighten over here, but I'm finishing over here, which means that I need to have a zone of tolerance in the shape of a cylinder, basically, which is securing that I will not be touching here, 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 or anywhere here. But on the other hand, the tool will not be disabled as I will move in the Z-axis. Yeah? So that's why we have all these different types of the zone. The system is actually on the market for over 15 years, so it's not something new. It was tested and validated by many different and really demanding applications, and those were actually one of the outcomes. Of course, for hand picking, I can let's say create the zone of tolerance, which will have the shape of the box, which is mostly for the picking. The beauty of the system that in this case I'm not controlling just the picking, but even the placement. Yeah? So I know where the operator was also placing the product. Of course, the tolerance for hand picking is normally set much lower. Generally we speak about, let's say, 3 to 5 centimeters, because of course the human hand is it's a living organism which can have some small minor modifications and movement. But still, even for this one, we are doing a sort of a hand calibration, which means that we are also calibrating the virtual point also for the hand. So if let's say I'm coming back from the lunch as operator, I'm putting on my tracker. The first thing I'm asked to do is just to press some button or touch virtual point in the area, and then the system is automatically teaching the distance between the tracker and the tip of my finger and calibrating the size of my hand. Yeah? Of course, we have some other solutions. As optional, we have laser guidance, so we are able to project in the area some laser projected information, such as gluing path, or maybe some instructions, some letters, some darts, some whatsoever need to be projected. So we speak about augmented reality from this point of view. We also were testing and which had a solution for the HoloLens, which was actually the augmented reality as you would imagine it by seeing it on a fair or on some technical news. The problem is that it looks really nice on the exhibition, but practically almost no operator want to work 8 hours with the HoloLens on. Yeah? So that's why we have this solution, which is really usable for 8-hour long working shift, because operator doesn't have any problem to see the information projected on his workspace, unlike having the HoloLens on. Yeah? So this is something which can be really used in the industry. Of course, the laser is certified, so the product is the balance between certified safety and good visibility in almost any light conditions. Just to mention, this laser is not measuring, it's just projecting. Yeah? When it comes to moving lines, we actually also have the laser which is able to measure the distance of the coming product. Now we are trial testing also the LiDAR, and but the simplest actually solution that we have for the moving lines is the reference tracker. So basically you are able to take another tracker which can be battery powered or can be charged from the pallet, from the AGV, from anything. And this one is actually allowing you to move the object without any problems, and the tracker in this case will be linked with the working tracker. So the reference tracker and the working tracker will be linked in the system. And then the system will be not measuring the distance from the camera, but it will be measuring the distance from the reference tracker, so I can really rotate the product or anyhow adjust it. It's quite often used, for example, on the AGV, because the AGV is parking with a precision around 5 centimeters. So if you want to secure the precision of 1 millimeter, the reference tracker is basically a need. Yeah? So this is basically Nexonar. Let's have a look on the practical presentation. As you can see, the system is instructing me where I should be placing the work order by this laser projected dart. Of course, I need to do it with the hand with the tracker. In reality, the operator will have the trackers on both of his hands. In this case, I need to use my left one. Yeah? So now it's confirmed. We can continue. We can start picking. I should be using the letter T. But of course, if I will use the wrong one and to make the validation, I simply cannot continue. I really need to go through, and I need to use the letter T. Once the pick is confirmed, I need to be placing the letter to the right spot, which is again projected by the laser. So once I will do it, I'm able to continue. Okay, so now letter O. Of course, as I was mentioning, we have the reference tracker. So if I will actually move the trolley anyhow, doesn't matter. The laser keeps following, so it's no problem. It's automatically adjusted. Yeah. Also, as you can see, it's even adjusting the aspect ratio. So it's on the curved shape. It's no problem. The system can deal with it. Yeah. Unlike the standard projectors, for example. Okay, letter A. I guess you might already have a guess about the word that we are assembling. So the last one. Okay. Now the system is instructing me to do the tightening. As you can see, my tool is disabled. Yeah. I only need to go to the place which is designed. I also have a laser dart over here. And here, as you can see, I have the information that I'm not in the position because this area is orange. So only if I go to the right spot, the area becomes green. And basically I can project almost any type of projection. And that's about it. Thank you very much.